Welcome to myprojectbazaar.com. Project title: New Power-Aware Multicast Algorithm for Mobile Ad Hoc Networks. Now we are going to see the abstract. In this process, we have doing the enhancement work for the base paper. Generally, wireless networks are the computer networks that are not connected by cables of any kind, which enables enterprises to avoid the costly process of introducing cables. Ad hoc wireless communication between the devices might be loosely defined as a scheme, often referred to as ad hoc networking. MANET is a type of mobile ad hoc network that has the characteristics of mobility and self-configuring, in which each mobile node not only acts as a host and it also acts as a router. Each node operates with the limited battery power to forward the data packets from source to destination. In MANET, multicast is a very useful communication system for group-oriented applications, where one-to-many propagations are needed frequently in critical situations. In this process, it presents a new power-aware multicasting algorithm for MANETs. Here, it uses the residual battery energy for multicasting from the source to a group of destinations. These networks are lack of fixed infrastructure and the nodes are typically powered by batteries with a limited energy supply wherein each node stops functioning where the battery drains. Multicasting procedures for routing in MANET becomes a major concern to support the propagation of data from a single sender to all receivers. For that, we propose a new protocol called PUMA, that is Protocol for Unified Multicasting Through Announcements, for performing the multicast routing. This protocol reduces the load on wireless nodes by selecting the route with minimum energy with maximum hop count within the multicast group. Finally, the simulation results shows that the performance of the proposed protocol is increased than the existing work in terms of its metrics like throughput, energy, and network lifetime. Now we are going to see the flow diagram. First, the network model is created in the network. After that, the nodes have the mobility model because since it is a MANET network, nodes are all moved in the transmission area. After that, the multicast group is created. In that group, the senders and receivers are mentioned. After that, the PUMA protocol is implemented. In that protocol, we have to find the path for the packet transmission between the sender and the receiver nodes. If the path is found out means then the data transmission is processed from a single sender to the multiple receiver. Else it again implements the protocol and it find out the path. Finally, the performance analysis is calculated, that is the matrices are defined which is comparative with the existing system. Let's see the output demo of our process. First, open the terminal window, then go to the directory where we have the code, then type ns space file name dot tcl. So this is the command for our code to run. So now the nodes are created in the network. After if running is completed, we can see the output in the network animator window. So this is the nav window to see the output. To play the simulation, click this button. So these are all the number of nodes that created in the network area. This is the simulation time that is run in milliseconds. We can speed up the simulation process. Since it is a MANET network, these nodes are all moved in within the transmission area. Now a sender and the multiple receivers are created in the network. These multiple receivers are belongs to a single group. That is, now we are going to perform the multicasting procedures in the network. The sender broadcasts its message to the multiple receivers with the help of the human protocol. So we can able to see this message is sent by using the Puma protocol. The sender sends the message. After that, this message is forwarded to all the receiver nodes which are belong to a single group. So this represents the multicasting procedures. To see the performance results, close this window and back to the terminal window. Give command for graph GNU plot file name .plot. This is the delay graph. In this, the group size are varied and we find the delay in milliseconds. We can able to see that the existing protocols are compared here. Our proposed multicast Puma have less delay compared to the other protocols. To see the another graph, type GNU plot lifetime.solve. This is the lifetime graph. The group size are varied in the network and the lifetime is calculated for each group size. Here also the proposed multicast Puma have higher lifetime than the other protocols. Thus the overall performance of the network is increased than the existing approaches. That's all. Thank you for watching this video.